Okay, I have a few examples of some exponential equations and how to solve them. All right, here's the type of equation you might get. First thing you want to do is take the natural log of both sides, since this equation has a problem in e. So if I take the natural log of e to the x equals the natural log of 72. Now, remember the exponent rules? What can I do with that x? I hope you thought of this. X ln e equals ln 72. Now at this point, you should know that ln e is defined as 1. So x equals ln 72. X equals, pick up your calculator, use the natural log key, and you get approximately 4.277. And there's the answer. All right, next one. On this problem, it looks like I might want to divide by 3 first. So let's divide both sides by 3. Then I get 2 to the x equals 42 divided by 3 is 14. Now, in this problem, since I don't have an e, I'm not going to use natural log. Remember, natural logs are logs to the base e. I'm going to use regular logs in this problem, but I could use a log to any base. This is an exponent, and the base of this exponent is 2, so I'm going to use log base 2 to solve this problem. So I could do log base 2 of 2 to the x equals log base 2 of 14. I chose 2 because of that base. What can I do with the x? Put it out in front. X log base 2 of 2 is log base 2 of 14. Do you know what to do next? That's 1. So x equals log base 2 of 14. Oh, I need to do the answer. I can't type that into my calculator. Do you remember the change of base formula? Of course you do. So this really equals log base 10 of 14 over log base 10 of 2. And when I'm using log base 10, I really don't need to write the 10 because it's understood. So log 14 over log 2. You can do that on your calculator. And make sure you close the parentheses. You should get approximately 3.807. Make sure you test these on your calculator when you do them. Okay, here's 2 more problems to solve. First step on this problem, e to the x plus 5 equals 60. How about subtract 5? Then I get e to the x equals 55. Do I take the log of each side or the natural log of each side? Natural log, I hope you guessed. You didn't guess, you know. All right, take that x, multiply it times the front. Some people skip this step. I like to write it. ln e is 1, so now we have x equals ln 55. And again, using the calculator, x is approximately 4.007. All right, let's do another one. A lot of action in this problem. I have this 2 multiplied by that quantity. I have a minus 4. What should I do first? You know, order of operations, right? Add 4. Okay, so now 2 times the quantity, 3 to the exponent, 2t minus 5 equals 15. What do you think we should do next? That's right, divide by 2. So 3 to 2t minus 5 is the exponent equals 15 halves. We'll just leave that a fraction. All right, should I take ln of both sides or log of both sides? I hope you chose log. Now, remember, I can do the log of any base. Got any ideas on what base would be a good one to use? I could use log base 10, log base 2. That's what we used in the last problem when we did this. How about log base 3? You know why I chose 3? That is the base. Okay, so log base 3 of 3 to the 2t minus 5 equals log base 3 of 15 halves. That wasn't so bad. Now what do I do? I could move this exponent to the front here. So let's put it in a parenthesis. 2t minus 5 times log base 3 of 3 equals log base 3 of 15 halves. Hey, what do you know about that? It's 1. We chose our log here to have a base of 3 because of that 3. All right, so now I have 2t minus 5 equals log base 3 of 15 halves. 15 halves, 7.5, right? So what do I do next? How about add 5 to both sides? So, do I have any room here? I guess not. So let's go. T minus 5 equals log 15 halves. I could write this as 2t equals 5 plus log. Can we write that as 7.5 at this point? And what base were we using? Base 3, right? Okay. Now what should I do? Divide everything by 2. So t equals 5 halves plus log base 3 of 7.5 divided by 2. I don't like how that looks. T equals 5 halves plus, how about 1 half log base 3 of 7.5. Oh, what can I do with that? Change your base formula, right? So I can do t equals 5 halves plus 1 half times the quantity, log base 10, 7.5 over log base 10 of 3. You can plug that into your calculator and hopefully you get 3.417. That was a longer problem. But I have confidence. You can do these. Okay, one more really hard one to solve. Notice this problem has 3 parts to it. This is a factoring problem. Notice this and this. It's similar to if I wanted to do this problem with substitution, I could call that a capital letter A. And this, so if A equals e to the x, what do you think a squared would equal? Square that, e to the 2x. So this problem could look like a squared minus 3a plus 2 equals 0. If I asked you to factor this, no problem. A, factors of plus 2. 2 and 1, or minus 2 and minus 1. Hope you know to use the minus. So this means a equals 2, a equals 1. But we didn't have an a in that problem. We had e to the 2x. When I have a problem that looks a little complicated, I factor using brackets. Factors of e to the 2x are e to the x times e to the x, just like a times a. Factors of 2 minus 2 minus 1. At this point, I have it equals 0 over there. All right, at this point, set each part equal to 0. So e to the x minus 2 equals 0, e to the x equals 2, e to the x equals 1 in this part of the problem. What do I do next? natural log of both sides. So ln e to the x equals ln 2 x e to the x, x ln e equals ln 2. We know ln e is 1. So x equals ln 2, and can I find the value of that? Oh yeah, I can. ln 2 is about 0.693. 0.693. Same thing on this side. So, ln e to the x equals ln 1 x ln e equals ln 1. ln e is 1, so x equals ln 1, or x equals the natural log of 1, right? So x equals 0. How did I get that? Remember the definition, ln 1? It's 0. I think if you plug it into your calculator, you can get that also.